welcome back for another lesson. Today we're going to be getting into the Pythagorean Theorem. Now, if you've ever learned about Greece, about ancient Greece, you may have read or heard something about a guy by the name of Pythagoras. He was born somewhere around 569 BC, and he was kind of well known as a philosopher, musician, astronomer, but for us, we'll most remember him as being a mathematician. He discovered something that revolutionized geometry for all when he discovered the Pythagorean Theorem. Well, it became the Pythagorean Theorem, but he figured something out along the way. And so we're going to kind of discuss what the Pythagorean Theorem is, how we use it. We use the Pythagorean Theorem to find the distance of missing sides if we're dealing with a triangle here, right triangle. And so let's say we have a right triangle like this one over here. And first of all, you can tell that a triangle is right usually if it has a little square over here. That little square that you see in its corner, it indicates that the triangle has a right angle. And that means it's 90 degrees here, and then the other two sides would equal up to 90 degrees. Now, when you are looking at a right triangle, we have three different sides. We have a side A and B, which you can call this side A if you like, and this side B. You could either make that one B at the bottom, or you could actually make it A at the bottom and B on the side. It doesn't make a difference because both of these sides are considered the legs. These are the legs of the triangle. Then the one that does have to be specific, this is side C. Side C, first of all, is always going to be the longest side of a right triangle, all the time. One way you can kind of tell as far as the length, what does the length have to do with the sides? The length is always connected to the angle opposite of the side. So if you notice that side C is the longest side, if you look over here, you'll notice that the angle, the right angle directly across from it, is the largest angle of the three angles that are inside the triangle. And then the next longest would be next to, I would imagine this would be our next biggest angle. And if you see, it is connected to the next tallest or next longest side. And so that's how they're connected. The bigger the angle, the bigger the side in proportion to everything else. But anyway, angle C is, or the side C, this is referred to as the hypotenuse. And again, the hypotenuse, this is the side C. It is the side that is directly across from the right angle. So anyway, what did Pythagoras find out? He found out that if I have any of the two sides, if I have sides C and A, C and B, I can find the missing side. If I have side A and B, then I can find out what the length of side C is. And the way he does it is he uses his formula that he came up with through trial and error, through discovery. Kind of like how when they figured out what pi is through discovery, the same thing here. Just kind of narrowed it down and figured out, hey, you know what? There are connections between the lengths of these sides, and working, it always seems to work out. And so this is the Pythagorean Theorem. If you have a squared and you add it to b squared, it will always equal c squared. We're going to use this formula all day, every day, when we're dealing with right triangles and trying to figure out the missing sides. Let's go ahead and try an example and see how this works out. So I'm going to put this over here, put this over here. All right, so again, we're going to say this is a right triangle, and we can give it any lengths we want. So let's go ahead and say that this side is 15 meters. We'll say down here, this side is 6 meters. And if I have both of these, we're going to have to say this other side is x meters. I don't know what it is. So what I'm going to do, again, if I'm going to refer to this as A and B, and this is C, all I'm going to do is I'm going to plug in the numbers into our equation up here. So where I see A, I'm going to make it 15 squared, because it's A is 15, and then you're going to go ahead and square it, plus b then is 6 squared. And c squared, we don't know what c is. We're going to go ahead and just write it as c squared. Now, if you have your calculator, you're more than welcome to square your 15, and you're going to end up seeing that this is 25, because 15 squared, I'll put this over here, 15 squared is the same thing as 15 times 15, which is 225. So we're going to have 225 plus 6 squared, which we have 6 times 6 is 36, equals, again, c squared. Now, if you add the 225 plus the 36, you're going to get 261. And again, this equals c squared. All right, this is the part where it gets just a little confusing. We want c to be by itself, but right now we have c squared. Now, you may have learned at some point that if you take c times c, that equals c squared. Much like 4 times 4 equals 4 squared. We're going to use that type of relationship. And so if I say, again, that 4 squared equals 4 times 4, that would have to mean, here I'm going to move this up a little bit. If I had 4 squared times, or 4 times 4 is 4 squared, that would have to mean that 16 equals 4 squared. And you may have learned this before. If not, this is called a square root symbol. I'm going to do the square root of 16. And so basically this is saying, what is two numbers that are the exact same I can multiply to get 16? Well, I can do 1 times 16, but they're not the same. I can do 2 times 8, and that equals 16, but they're not the same. I can do 4 times 4. Now, they're both the same number, so the square root of 16, which is the square root of 4 times 4, would then equal 4. And so the square root of 4 squared would then just be 4. So keeping that in mind, we're going to go ahead and we're going to use the same type of thinking to solve this problem. So I'm going to find out what the square root of 261 and c squared is. So we already know that c squared would be c times c, so the square root of c squared would then just be c. And then the square root of 261, we're going to make this an approximate because it's going to come out not equal. So we're going to do the square root of 261. So you put this in your calculator and you would find out this is, I'm going to just do it to the nearest tenth. Actually, we'll do it to the nearest hundredth. This is 16.15549,442, which would end up being 16.16. And then we're going to go ahead and make it meters. Okay, so that would be our first problem. That's how we're going to figure out what the using the Pythagorean theorem to find out our missing side. That's how we do that one. Now I'm going to go ahead and scroll down. We're going to do another one here. And again, we have a right triangle. Again, I know it's right. Usually you'll have a little square there that will indicate it's right. And again, this is my side A or B. This is my side A or B. And this is always my side C. I'm going to give you one more example where we're going to be looking for C, and then we're going to make it a little bit tougher and try to find one of the legs. So we're going to go ahead and say that side A is 5 inches, and side B is, we'll see what happens. We'll make this 5 inches as well. Let's find out what happens. And here, we don't know what it is. We're going to say it's X inches. We don't know how many inches it is. So over here, we're going to go ahead again and put our Pythagorean theorem, which is a squared plus b squared equals c squared. And then again, we know that a is 5, so it's going to be 5 squared. We know that b is 5, so it's going to be 5 squared. And then c, we don't know what it is, so it's just c squared. 5 squared is 25, because 5 times 5 is 25, plus, again, 25 equals c squared. And then 25 plus 25 equals 50. And then that equals c squared. We're going to do the square root of both sides, just like we did before. Now, the square root, we have perfect squares. For example, 4 is a perfect square because 2 times 2 is 4. 9 is a perfect square because 3 times 3 is 9. 49 is a perfect square because 7 times 7 is 49, so we know that this is going to be extremely close to 7. When we go ahead and do this to the nearest hundredth, again, this is an approximate, we're going to have down that C is approximately 7.07 inches. And that is how we would solve this problem, to find the hypotenuse in this triangle. We're going to try one more, just to make sure you're getting this. Let's go ahead and make one more triangle up. Make sure it's a right triangle. And let's do it this way. We'll expand it a little bit. There we go. Okay, so with this one, again, we're going to say it is a right triangle. This time, I'm going to go ahead and say the hypotenuse is 13 centimeters. And we'll say this leg over here is, we'll say it's 12 centimeters. And we'll say that this one, I don't know what it is, so this is going to be X centimeters. Now again, we don't want to confuse this. This is leg A or side A. This is leg or side B. This is our hypotenuse or side C. So we're going to go ahead and we're going to plug in our numbers into our Pythagorean theorem. Again, the Pythagorean theorem, A squared plus B squared equals C squared. Okay, this one's a little bit different because we're going to have C from the very beginning. We know that C squared is going to be 13 squared. And we're given A or B, however you want to look, we're given B actually, and B in this case is 12 squared. We're not given A. A this time is going to be, you can write it as A squared, or if you want to, you can put X squared. Well, I guess we can go ahead and put it as A squared. We'll leave it as A squared. Okay, and that's to figure out what the missing side X is. And so we're going to go ahead and finish this next line up. So A squared remains as A squared. 12 squared is 144. And then 13 squared is 169. Okay, now, what do we do now? Well, if you've spent much time with equations, you know that you're going to have to get that A squared by itself. And so the only way we can do that is by getting rid of the 144. And you get rid of adding 144 by subtracting 144. So we're going to subtract 144 from both sides. We end up getting A squared equals, well, it's a 5, and that's a 2. We end up getting 25. Hey, this one's going to work out pretty evenly. So now we're going to go ahead and find the square root of both sides. And we're going to get A equals 5, and in this case, centimeters. Okay, I hope this helps you understand how to do the Pythagorean theorem. Make sure you tune in next time as we, I think next time we're going to get into multiplying and dividing rational numbers. That's fractions with negative signs. Good times. So you guys have a great day.